Okay, can you see my screen well?
Perfectly.
Okay, so let's get started. Hello everyone. Thank you very much for having me in OCP Tech Week. My name is Jung-Soo Kim from Samsung Memory Division, and I'm going to present today about the Poseidon Project and innovative new SSD design called Toolless SSD Extension Kit. So I will go over the detailed system design and important design decision points for performance and efficiency of the, especially SS form factor. And I'd like to share how we utilize the open source community to develop a SSD reference system, which leads to the development of Toolless SSD kit. So after that, my colleague Yusuf here, we are in the same room. And Yusuf will share the details of Toolless SS kit design at the end, and I will talk about some future plan. Okay. So let's talk about the data center storage system trends. Modern data center storage system architecture is evolving towards the disaggregated architecture. The reason why is many workloads such as machine learning and AI, big data, their data sets are not fit in a single server. With a traditional direct attached storage architecture, you will need many SSDs and CPU resources to run a huge amount of storage pool. However, by decoupling storage from compute, you can reduce the complexity and increase the performance and efficiency of the infrastructure. For example, you can increase the CPU and SSD utilization because you can optimize resource allocation in a pool. You can also decrease the TCO of infrastructure by reducing the storage spending. And the flexibility of infrastructure will increase. You can dynamically allocate the compute and storage resources of a shared storage pool, which will result in higher utilization and bigger CapEx savings. So NVMe Fabric is a standard network storage protocol to enable such disaggregation of storage pool. So we started Poseidon Project. We named the project Poseidon in a hope that various solution providers and customers can get together in one ocean. Poseidon is all-flash array storage server that can be referenced to the industry. The three leading Asian companies have set up a plan to carry out the design, development, and evaluation of a storage system together. So we collaborate with Inspire and Neighbor Cloud with the goal of open source based innovation. Not only the hardware system, but the software is developed as an open source hardware, especially targeted for OCP community contribution in mind from the beginning. And all hardware and software design will relate to this will be open through OCP and the GitHub. So we define the Poseidon system as open source, high performance shared network storage system for NVMe Fabric. We hope that by open sourcing the system, we can expand NVMe and EDSF ecosystem. The Poseidon system is storage server with enterprise data center SS form factor, EDSFF. It was emerged to overcome the limitation of existing SSD form factor like 2.5-inch and M.2. And EDSF enables the improved system density and performance of the storage. And the system offers high bandwidth and low latency I/O. Is PCI Gen 4 based system and supports DDR4 3200 main memory. The reference system has up to 32 E1S SSDs and supports up to 256 terabytes of storage capacity in one new server. And the new form factor EDSF enables high dense and highly efficient system design. Since our target customer is a data center partner, the system offers data center reliability like hot swappable SSD and PSU, dual port NIC, and storage rate and hot spare. And the system has NVMe TCP offloading engine to maximize to minimize the latency and offload the CPU resources. So this is an overview of a system design. We just got some samples of system. In front of the system, there is a E1S SSD drive base, and the system can accommodate 32 9.5 millimeter E1S SSDs. And behind the SSD is the connector and backplane. The system especially uses horizontal backplane with orthogonal connectors. We designed the backplane to install power module for NVDIMMs and PCI switches. To maximize the performance of the storage I/O, Poseidon OS stores the metadata in NVDIMM memory. So I will share some more details about our backplane design and connectors later. And there are 8 40 millimeter dual motor fans and the motherboard. So the CPU supports the latest PCI Gen 4 and has a channel 2 DPC memory configuration. So you can have total 16 DIMMs in each CPU. On the rear side, there are 2 full height and half-length PCI slots with 1 OCP NIC slot, and there are 2 Haswaro PLCs. Okay. So this is a system diagram, and it shows the PCI topology of a Poseidon system. Since the Poseidon OS recognizes the NUM architecture, the topology is designed symmetrically to minimize the latency and offer stable I/O. So as you can see, each SSD is connected 4 lanes to maximize single SSD performance, and total 16 SSD are connected to each PCI switch. And on the downlink side, there are total 64 PCI lanes. In uplink side, and 32 lanes are connected to each CPU, and there is another 16 PCI 4, 16 lanes connected and PCI slot for network controllers. So obviously, the PCI slot for NIC limits the total bandwidth of the system. But however, we assign the full PCI lanes to every single SSDs and use the PCI switches with several reasons. First of all, most I/O doesn't occur simultaneously all SSDs. By assigning the full bandwidth to every SSD, the system allows the best performance for most of I/O operations. And Poseidon OS offers software rate to protect data, and east-to-west traffic performance is important inside of the system when the system reviews the rate. So if you want to optimize the cost of the system, you could deploy a single socket without PCI switches, but you will need to decrease the number of SSDs or PCI lanes of the single drive. So I'd like to mention that the PM983 SS spec table is a little bit out of date. So I will update the latest data for final version. So as I mentioned, our target application is shared storage node for NVMe Fabric, but the system also can be used as a high performance application like a database. We targeted PCI Gen 4 based system with over 200 gig Ethernet bandwidth, and we simulated PCI Gen 4 E1.SS SSD. Power consumption was less than 13 watts. And our data center partner wanted less than 4 terabytes of a single SSD drive capacity, because they wanted to minimize the rebuilding time when a driver fails. And we wanted to meet OCP NVMe SSD airflow recommendation to increase the system power efficiency further. So I think everybody talking about the disadvantage of conventional SSD form factor. We also believe that EDSF is a design for overcome conventional form factor limitations. So M.2 form factor was developed for client use and is mostly used for boot drive in data center, and it has limited performance, power, and scalability, and doesn't support hot plug. U.2, which is the most popular form factor these days, but it was evolved from 2.5-inch hardware form factor. So even though it's most popular, it still has the power limitations and disadvantages for high-speed next-gen interfaces like PCI Gen 5 and 6. So we have investigated SSD form factor very carefully when we designed the system to find the optimal SSD form factor for NVMe Fabric target node. Even if E1.X form factor, there are 7 different kinds of form factor, as you can see on the table. Since one of the data center requirements was less than 4 terabytes of a single SSD capacity, we decided to choose the E1.S rather than choose E1.L. Among the E1.S form factor, still there are 5 different kind of thicknesses. So as you can see, as the thickness is getting thicker, the power capacity is getting bigger, and as thickness is getting thinner, the system density is getting higher. So, according to our simulation results, 9.5 millimeter or less was optimal thickness because the power consumption of PCI Gen 4 E1.S SSD was less than 13 watts. And it offers the highest density compared to the other thickness. We also simulated the SSD to see the thermal characteristic of E1.S SSDs. According to the OCP NVMe spec, the airflow recognition, should be no more than 1.5 millisecond in 35C ambient temperature. On our simulation, only 9.5 millimeter satisfied the OCP NVMe spec among the 5.9 and 8.1 millimeter. So we concluded 9.5 millimeter is the best fit for shared network storage system in terms of the power, performance, and the density. We also adapted horizontal backplane and the orthogonal connectors to improve airflow of the system. As you can imagine, with a traditional vertical backplane design, the air passage is very small, which causes air impedance increase. We also simulated 2 different kinds of backplane design, vertical backplane and horizontal backplane. As you can see on the red circle, there is some turbulence with vertical backplane, which increases air impedance of the system. We also found that you can lower the SSD temperature by 1 to 2 degrees C by adapting the horizontal backplane. And also the orthogonal connector will increase the system efficiency further. So in summary, we chose E1.9.5 millimeter SSDs and orthogonal connectors with horizontal backplane design to optimize system performance and power and density and so on. So we announced this Poseidon project and system at the last OCP Virtual Summit, and we got various feedbacks from customers, including the data center all over the world. One of the feedbacks that we got from the data center customer was they wanted to remove the screws from E1.S SSD so that they don't need to use tools in the data center. So we started to develop the tool-list SSD design. And from now on, our mechanical engineer, Yusuf, will share detailed design of tool-list SSD. Yusuf?
Thank you, Johnson. My name is Yusuf. I am senior mechanical engineer. I will go over Samsung proposal on toolless extension kit for E1S Enclosure. In current application, extension kits are fixed on enclosure with 2 screws, and the assembly and disassembly process takes long time. One way to improve data center serviceability is to reduce the assembly and disassembly process time. We would like to create a toolless assembly concept by removing screws that could reduce the process time dramatically. Since E1S enclosure is created to use with screw assembly concept, it's not easy to develop toolless extension kit design without enclosure modification. However, any modification on enclosure should not violate the current spec because the current extension kit assembly with screws are only option in the market, and any major design change on enclosure could cause assembly issues to the server system. So we would like to create a toolless extension kit with no or minor enclosure modification. For the toolless extension kit concept, we came up an idea of easy to use clip type design concept. We added lever with spring and redesigned the extension kit all over again. The proposed extension kit can be assembled to the enclosure quickly and easily thanks to clip type locking mechanism. In next page, I will explain how it works. If the lever is pushed down, you can place toolless extension kit into the assembly position. Releasing lever will lock extension kit to the enclosure due to spring force. Toolless extension kit can be assembled and disassembled easily and quickly by pushing on the lever when latch is open. Closing latch fully locks extension kit to the enclosure, and extension kit cannot be removed from enclosure at this point because the latch supports the lever as shown in the red circle in below image. I would like to show the efficiency of assembly and disassembly process. The process for current and toolless extension kit can be seen side by side. Let me play this. Assembly and disassembly process of toolless extension kit takes only 4 seconds, which is up to 10 times faster than current extension kit. That is huge improvement considering if data center has millions of drives, needs to be maintained over time. Time saving is added up and 100,000 hours. In other words, $2.5 million can be saved over time just for a data center. Minor modification on enclosure is needed to assemble the proposed toolless extension kit. The current extension kit is fully compatible with proposed enclosure design as well. Toolless extension kit concept can be adopted by E1S device with different enclosure thickness. We would like to contribute toolless extension kit to the OCP community and have your feedback to improve toolless design concept. Your feedback on toolless extension design is greatly appreciated. Now I am going to hand over to my colleague, Jong-soo. Thank you.
Okay, so thank you, Yusuf. He's the great mechanical engineer, one of the main engineer who developed the toolless SSD design. So I think not only the data center, but the system vendors can also benefit from this toolless SSD design by reducing the assembling time. So I believe that we have solved industrial problems based on the open philosophy. So Samsung partnered with system vendors and data centers, and we developed the Poseidon system together as open source hardware. After announcing the project to OCP Global Virtual Summit, we have gotten great feedback from the industry. And they shared their requirements and pain points to us. And we started the toolless development project, which we understand very well. So I think this is a great example to prove the virtuous cycle structure of open source community. We will open our development back to the community just as we got help from the community. So next step, we will run some real world application on top of the Poseidon hardware and software. Hopefully we also run some benchmark tests, especially for AI workload. For the toolless extension kit, we want to run some feasibility tests with the data centers. We really expect to have many feedbacks from OCP community so that we can improve our design. So after finalizing the design, we will contribute the design to the OCP. Call to action, yes, please join us, share your feedbacks, and collaborate to build NVMe Fabric and EDSF or E1S ecosystem together. We are looking for new use cases, system designs, and more. So for toolless SSD, we expect various feedbacks from the community members. And let's work together to upgrade design and finalize the spec. Yeah. Thank you. And should you have any questions and would like to contact us, please email us. And thank you for listening to our presentation. Right. Thank you.
Thank you, Jung-So and Yusuf. That was fantastic. I'm looking at we don't have any questions currently in the FN virtual app, but do we have any questions currently with some of the people on Zoom? So we'll open it up. All right, if people are still formulating questions, I do have a question for you. I think
Sure.
the concept you have for the latch is fantastic, and then it's an excellent, you see a problem, you guys innovated on top of it, and you're willing to contribute that back to the community. The question I have specifically, though, is do you have the LEDs light piped out into the latch space? And if so, can you just point them out for us?
Yes. Can you see our pointer?
It's just over
Yeah.
here.
Yeah.
Can you see? Two light pipes.
Yeah, that's the light pipe.
Okay, so it goes into the two holes. So as it swings open, it just, I got it.
Sure.
Yeah.
And I'm not sure if everybody else caught this, but there are some changes that would be required for the E1.S form factor, specifically on that mounting tab.
Yes, that's right.
By opening that up to the open compute community, it lets us all take a look at this, look at the benefits it provides, and then if we really need to open up the spec to E1.S, if we see enough value as a team, that it's worth opening that again. I personally think this is fantastic.
Thank you for comment.
Do we have any other questions or comments?
All right, so maybe next steps. So this is a great kickoff presentation. If we can send some of the details specifically on the carrier to the mailing list. If you have an early version of a step file, if you want to put that out to the mailing list, we can have this on the agenda for the next monthly meeting. So we're in November right now, but the December meeting, we can put this on the agenda, collect feedback as people digest, what this means to them, if they have questions or concerns that allow people to reach out.
Okay, I think that's the good idea. So we will share our design step file first to the community storage project, and let's discuss our design, toolless design for the E1.S SSD. So the strength of this toolless design is it not only for the 9.5 millimeter thickness, but it's for adaptable to 15 millimeter and 25 millimeter because they share same extension kit design. So it's very, it also compatible with current extension kit, as Yusuf mentioned. So you don't need to change your screw extension kit. So you can share a same SSD enclosure. So we will also share our design to the community, as Jason mentioned.
One other question I have, since there are not too many other questions at the moment. For the 15 and the 25, where you have the space, is it possible to make a latch design work without changing the E1.S screw hole cutouts? I don't know if that angle works, but have you considered a way to make it work without changing it?
Yes, we work on various designs, but we found out the grip strength and reliability wasn't good. So we changed just this design to increase the grip strength.
Okay.
So have you guys, you're planning to contribute this, right?
Yes.
To OCP. Does it make sense to have a discussion in SFF about this and whether that cutout is, would even be considered by the ecosystem?
Could you revise your question again, please?
To use this latch, you really need that change, right? To the,
Yeah.
and I'm wondering if we should discuss that in the SFF committee where the spec lives.
Yeah, yes, definitely.
So we haven't.
If you haven't already, I don't know if you have, but I think.
No.
We haven't talked to the EDSF committee or SNIA yet. So we opening to OCP committee first, and after we finalizing the design, we hope that we can discuss with the SNIA or EDSF.
Okay, so you want to wait till you get a few more comments in reaction to this before you go there.
Sure.
Correct.
Yeah, that's the way to go we want.
Yeah. Okay.
Yeah.
Thank you.
Cool. Yeah, it's really clever. It's really.
Right.
I was going to say the next storage meeting is on December 10th at 7 p.m. Eastern. And I posted the link where you can get all the details in the Etherpad. So if you're interested in attending that, that would be fantastic.
Right.
Yes, we definitely can wanna attend that meeting.
Excellent. We look forward to more of a deep dive there. And if you want to help seed the questions, if you share some of the presentation material, and if you add a step file to the mailing list, that'll give everybody a chance to look ahead of time and hopefully come prepared with more questions.
Yeah, I think the presentation is available here, but yeah, the step files and such definitely be easier there.
Sure. All right.
So, Jason, we have about 2